All right, so a grocery store manager, this is your stat sensei, and this is Chi Square GOF Scenario 2. A grocery store manager wishes to determine whether a certain product will sell equally well in any of 5 locations in the store. So they want it to be, when I say sell equally, they're looking for it to be the same or uniform. All right, 5 displays are set up, 1 in each location, and the resulting numbers of the products sold are noted below. So this is what we actually sold: 43, 29, 52. So those are where the 5 locations were. That's 206 items that were sold. And so we would expect to sell, if we sold a total of 206, and by the way, it really helps to total these up at the very beginning. So 206 divided by 5 tells me we would expect to sell 41.2 at each location if they were selling equally well. Well, we notice real quickly that we have some variation here, all right? So they ask us to test at the 10% level of significance. The product location sales data follows a uniform distribution, or the sales data for the products is the same for each location. The product location sales is not the same for each location, or does not follow a uniform distribution. Remember, uniform distribution, everything is the same. All right, so I know I'm going to point to real quickly that on the recipe, on our conditions, we need n is less than 10%. So random sample, n is less than 10%, all expected values greater than 5, and everything needs to be counts. Okay, well, it turns out that they're not looking so much that you include the counts anymore. They're asking for the n is less than 10%. So random sample, not given, but the sample is assumed to be representative of the sales data. All right, n is less than 10%. 206 divided by 0.1 is 2,060. So we would anticipate that they would be selling more than 2,000 items a day, or whatever their time frame is, a week, whatever it is. We would expect that they're selling more than 2,000 items. The expected values, when we look at the table, they're 41.2. They're all greater than 5. And all the observed data are whole numbers. And this is something you need to check. Don't need to list, but all of these need to be whole numbers. Okay? So once again, we have 1, 2, 3, 4, 5 locations. So that means we have 5 categories. So our degrees of freedom is 5 minus 1 equals 4. And the formula, observed minus expected squared over expected. So in this case, 43 minus 41.2 squared divided by 41.2 plus 29 minus 41.2 squared over 41.2. And the et cetera, et cetera, et cetera. But we can bookend it and do the very first one and also do the last one. All right. And we end up getting this. Well, how did I do that? Well, I need to take a moment here, and I'm going to pause this while I input the data so you don't have to wait for me. So I've taken a pause and I input all that data, and the observed values, the 43, 29, 52, 34, and 48 observed data goes into L1. The expected data goes into L2. Once I've done that, I can go stat, test, chi squared, goodness of fit, or GOF, G-O-F, goodness of fit, L1, L2, and I had 5 categories, or 5 locations, minus the 1, gives me my degrees of freedom of 4. I calculate, and I get a chi-squared value of 8.9 and a p-value of 0.06. That's less than 0.10, we reject the null. So our p-value is 0.0636, we reject the null. There's sufficient evidence at alpha equal 0.01 to suggest that the distribution of data does not follow the uniform distribution. All right, in this case, we reject the null. Product placement is the same, is not the same for all 5 locations in the store. In other words, product placement sales varies. All right, product placement sales is not the same for all 5 locations. It's different. We sell more at some places and some and less at others. We have our contributions here at the bottom, and if we scroll across, we can sit there and see the contributions. There'll be 5 contributions. The largest contribution is the 3.6. So that's the second one. And that's 29 minus the 41.2. This is the biggest difference. And we know that it's actually, that has lower sales, all right? So that one's actually ends up being negative, but it has the, but everything being squared makes it a positive, and that ends up having the largest contribution. It impacts the chi squared the most. But once again, this plus this plus this, if I add all 5 of them together, I get 8.903. So product location 2 differs the most from the expected and is below what is expected. Product 3 sells the most and is above what is expected. Okay, so that's chi squared goodness of fit scenario 2. Hope you'll hang around for the next one. Thank you.